I do have a brother named Ryan.
Okay. Lesson 7.3 is where we are working today. And lesson 7.3 is more power rules. I talked about these a little bit at the end of the class on Friday. So we kind of already talked about the fact that when you have a power raised to a power, you're going to multiply the exponents. Okay, so what we were doing previously is if the bases are the same, you keep the base and add the exponents. Here, it's a power raised to a power, so we're going to multiply it. And these are all just some examples. 5 to the 4th raised to the 2nd, 4 times 2 is 8, 5 to the 8th. M to the 3rd raised to the 5th, 3 times 5 is 15, m to the 15th. This is just using fractions. It's the same thing. You multiply the powers. Have more confidence. We can do this. Now, raising a product to a power. To raise a product to a power, the difference is if there's multiple things being multiplied inside the parentheses, the power goes on all of them. So if I have A times B, that power of n goes on all of them. So, for example, 3x raised to the 4th, that power of 4 goes on the 3 and on the x. So 3 to the 4th, x to the 4th. Thus, you see the 81x to the 4th. So those are some of the things we're going to work on there. And we'll talk about that one a little bit more when we get down to a problem like that. But 27 to the 2/3 and u to the 2/3, I'm probably going to go ahead and introduce what will come up in another lesson or two. So, right now, let's just jump into examples. That's what you guys do best with, right?
Sure. I'll do the first one.
So, Robbie's locker is just down over that way, right?
Yeah.
Okay, try the first one. P to the 5th, raised to the 4th. What did you say? Yeah, that'd be right. Because we're going to keep this base of P, and then we're going to raise the power. 5 times 4 is 20. Anything else we need to do here? No. P to the 20th is P to the 20th. Okay. What about the next example? Not exactly. Because we have P to the negative 5th raised to the 4th. So again, you're multiplying those powers. And negative times a positive is a negative. So P to the negative 20th. Now, notice, I didn't box the answer. I put equals. Okay, we learned this last week. Yep. You know what to do with negative exponents. Don't tell me you don't. Yep.
Oh, yeah. You gotta flip it to the bottom so that it's 1 over b to the negative 20.
Yeah. Does that sound familiar? Negative exponents, to get rid of those negative exponents, you move it across the fraction bar. And so this becomes 1 over p to the 20th. I'm thinking he did. Okay, now, on this next one, I'm going to give you a hint here. Think of that as x squared times x to the 6th raised to the negative 4th. Work on that x to the 6th raised to the negative 4th first.
She found them. I think I do. I don't know. I don't understand. Did you find them?
I found him. minus the notes.
What are you doing out there?
Somewhere here I have an extra set. Here. Now, is this your first extra set? Or have you already had another extra set? I can't remember.
It's his first one.
Okay. Okay. So we worked on the first two, so get caught up quickly, please. P to the 5th raised to the 4th was P to the 20th. We're multiplying powers here. We're getting ready to start example 3. Don't poke an eye out. You still have a pencil for yourself, right? Really, Lily? Okay, put the iPad up. You have your pencil.
I called it.
Okay. Welcome. Okay. Example 3 is where we're at. X to the 2nd times x to the 6th raised to the -4th. As I said, think about that right there first. Less than 7-3, if I didn't leave you on the right page.
-8. Oh, wait, what's that?
7-3.
Oh, wait a minute.
It's X to the 24th, right?
No, it'd be 4. Oh, I think 20. Yeah, it is. 20.
6, 12, 18, 24.
Okay, so a power raised to a power. We're going to keep the x, and 6 times -4 is -24. Now, is that the only part of the problem, though? No, there's also an x to the 2nd. So notice I went ahead and did the power raised to a power, and I carried down the other part. Okay? How do I do x to the 2nd times x to the -24th?
Oh, you gotta add it. X to the 22.
Okay, so this is where we're back to using the other rule. If the bases are the same, keep the base and add the exponents. So we're going to keep the base of x. 2 plus -24 is -22. Okay, so my question was going to be, am I done? Should I box it? Not quite. So if it's x to -22, to make it negative, we take it to the denominator. So now 1 over x to the 22nd. Okay. Okay. Same process, folks. 10 to the 2/5 raised to the -5/3. What are we going to do with this base? We're going to keep the base. What do I do with the powers? Power raised to power, we're going to multiply. So, we're doing 2/5 times -5/3. What do you notice about those fractions?
They're flip-flop.
No, they're not.
Like with 5.
Okay, well, what's important? The 5s are one on top, one on bottom, yes? I'm going to say that we can cancel them. A 5 on bottom cancels with a 5 on top. Now, don't lose that negative, though. That negative's still there. Okay. The 2 and 3 have to stay, don't they? So, what's going to happen when we multiply? Well, no, keep them on. And I guess I should say when these 5s cancel, those are 1s, aren't they?
Yeah, I forgot.
So 2 times 1 is going to be 2, or I guess I should say 2 times -1
Yeah.
should be -2. 2 times, or 1 times 3? 3. So at that point, we're at 10 to the negative 2/3. One more step. How do we get rid of that negative exponent? Move it to the bottom, so it's going to become 1 over 10 to the 2/3. It becomes positive when we move it down there, right? So then, if we were like that, we'd have to do it differently. But we can't take any root of 10, so. Now, you ask me the next examples. Well, I was going to almost say easier, but I guess it's not quite easier, but it's not bad. Okay. Don't do that. You're going to make me yawn here. I'm holding it back. Can't find it.
Wait, do I get $1 every time I make you yawn?
No, definitely not.
Yeah.
Reverse effect. You owe me $1 every time you yawn. Okay. A to the 1/9 raised to the 3/4. What do we do? Power raised to a power. So we are multiplying. I like to cross cancel. I don't know if you guys necessarily do, but I do. 3 and 9 can both do what? They can cancel each other out, right? 3 divided by 3 is going to be 1. 9 divided by 3? 3. So then, we're going to have A, 2, okay, what remains on top? 1 times 1? 1. Over 3 times 4? 12. So A to the 1/12. Okay. T to the 1/4 raised to the 3rd. Again. What am I going to do with these powers, Robbie? Well, multiply. I wouldn't say cross multiply. Maybe cross cancel if we can. So if I'm multiplying, it's 1/4 times 3. What's 3 as a fraction? 3 over 1. Okay. Is there anything that can cross cancel here? I mean, the ones could cancel if you want to think that way, but then they cancel to be 1. So at this point we have 1 times, go across. 1 times 3 is 3. 4 times 1 is 4. T to the 3/4. Can I go any farther?
Last Monday was not feeling like Monday. I got hit by mosquitoes and can't stop it.
Well, it's definitely a Monday, so.
That's what it is. It feels like a Monday sometimes.
Okay. W to the negative 2nd times W to the 7th raised to the 3rd. Where's our starting point here? Okay. Let's worry about power raised to power. So W to the negative 2, I'm bringing down. Power raised to a power. What are we doing with those, Lily? Multiplying. So 7 times 3 makes this W to the 21st. Now what? Do I multiply again? No. My bases are the same. Keep the bases, add the exponent. So then, what is negative 2 plus 21? 19. So w to the 19th. It's a positive exponent. So we're just going to leave it as is. You guys see that all right?
Yeah.
How many points do these notes, where do we turn these into at some point?
Depends, not necessarily.
Okay, well, last year she did.
Yeah, I know Mrs. Rogers does points for the notes. I don't necessarily do points for the notes. To me, it's more usually it's your benefit to be doing the notes. Now, I expect you to see you doing the notes. And I'm going to bug you if you're not doing the notes.
I just didn't know.
Yeah, no. You're not trying to get on your iPad, are you? Okay, I don't want you on your iPad. We've got math to do here. You'll be on your iPad soon enough, but... Okay. What about this one here? 9w squared raised to the 1/2. What does that 1/2 have to go with? It goes with the 2. What else is it going to have to go with? So the 2 is part of the w squared, right? What about this 9 here?
Oh, so it goes.
It has to go with the 9 as well. Meaning I'm going to have 9 to the 1/2. And then w squared raised to the 1/2. What do you do with a power raised to a power? We multiply. What is it? 1/2 times 2. What's half of 2? 1. Okay. So that's going to be w to the 1st. Now, okay, we haven't gone over this yet, and they actually teach this in 7.5, I think. But they're not going to let you leave 9 to the 1/2 because 9 to the 1/2 can go a little farther. Now, I'm debating which way I want to teach this. 9 can be rewritten as a square. And how they would show this doing this is they're going to say 9 is 3 squared raised to 1/2. What I tend to teach is, okay, if there's a 2 in the denominator, that says that this 2 says to take the square root. Can we do the square root of 9? What's the square root of 9? 3. In other words, square root, what number times itself, yes? So 9 to the 1/2, this is going to be 3. W to the 1st is the same as just saying W. And so this answer is going to be 3W. So the point I was trying to make is 9 to the 1/2 is the same thing as saying the square root of 9. Okay, when you have that 2 in the denominator, it says to do the square root. Okay, so you might see those a little bit. We'll talk about those more in lesson 7.5, which we'll hit later this week. But I wanted you to kind of see that. Okay? Okay. Let's try this one then. Very similar to the last one I just did. 16b to the 1/4. Well, what's this 1/4 go with? It goes with the 16 and it goes with the b. They don't have any other exponents, so I'm going to say 16 to the 1/4 times b to the 1/4. Now, this is another one. If you see some of these, look for them today. The 4th root of 16. What number multiplies by itself 4 times to get 16? Not 4, because 4 is only twice. 4 times 4 is 16, so that's the square root. Since this denominator is 4, I'm really looking for the 4th root. That's a good guess. Think about it. 2 times 2 is 4, times 2 is 8, times 2 is 16. Okay, so this becomes 2, and then we're going to leave it as b to the 1/4. And again, as I said, we'll work about those a little bit, but that's just saying the 4th root of 16 is equal to 2. Now, get what you need there. We'll flip it over and look at the back. I'm trying to think. Debating how many of these I want to do, but okay. Let's do this first one. I think I'm going to drop down to a different row. 7 m to the 9th raised to the 3rd. What's that 3 go with? Yep, the 7 and the m to the 9th. So then we're going to have 7 to the 3rd. M to the what? 9 times 3, which is 27. Yep, thank you. You got it. Now, my guess, I don't know, if it's a simplified expression, they want you to go one more step. How do we do 7 to the 3rd? What's 7 to the 3rd mean? 7 times 7 times 7? Yeah, 7 times 7 is 49. 49 times 7. Yeah, it's not one you guys have memorized. 7 times 49.
No. 7 times 7 is
7 times 9 is?
Oh, I really don't know.
We don't know 7 times 9?
I'm not good with my sevens.
What about your 9? Someone was talking about knowing the 9s the other day.
That was not me.
Or is that a different class?
It was Lily.
I know. Wait, my question.
Someone was talking about knowing their 9s the other day. I thought it was this class. I'm wondering if
What
it was a
question did
different
you
class.
ask?
7 times 9.
63.
She knows them. Okay.
See, I told you.
Bring down the 3, carry the 6. 7 times 4? 28 plus the 6? 34.
See, I'm not good at math.
7 times 49? 343. Well, then by all means, guys, you should have a calculator by your side.
I know.
She might have a calculator.
Well, that's fine for class, but your human calculator cannot help you on a quiz or a test. So, only Lily's human calculator can help her on her quiz or test. Okay, so 343 m to the 27th. Okay, let me pick a different one here. Let's go to the one directly below it. How's that work for you guys? I want to get you guys working on homework a little bit, and if we do all of these, it's not going to happen. So, let's try this one. X to the negative 2 raised to the 2nd times 3x y to the 5th raised to the 4th. Okay, where do we start? Yeah. X to the negative 2 raised to the 2nd. A power raised to a power, we're going to multiply. This becomes x to the what? Negative 2 times 2 is negative 4. Now, next parenthesis. 3xy to the 5th raised to the 4th. What's that 4 go on? Ah, good. 3x and y. So that means as I write this out, I'm going to have a 3 to the 4th, an x to the 4th, and a y to the 5th raised to the 4th. 20th.
Oh, yeah.
Did we forget about the 4 already?
Yeah.
Can't forget about the 4 that quickly. Now, okay, we've got the basics. We've got to do some cleanup here. Thoughts on anything you see that needs done? Add what? Yeah. Notice we have like bases with the x there, don't we? What's x to the negative 4th times x to the 4th? Okay, the x's are the like bases. We can only put like bases together. So here we have x to the negative 4th times x to the positive 4th. So keep the base of x. Negative 4 plus 4. That's 0, isn't it? So that's x to the 0. We still have a y to the 20th I'm going to carry down. Anyone done the math on 3 to the 4th? That's 3. Okay, here's the easier way in my mind. 3 times 3 is 9, yes?
Yeah.
Another 3 times 3 is 9, yes?
Yeah.
What's 9 times 9? 81, I hope?
I don't know. I was thinking it was less than.
Okay. So there's my 3 to the 4th. There's my y to the 20th. And my x's. Okay. I want you to do one more cleanup before you circle that answer and call it done.
Okay, you don't need the x.
Yeah.
It's just 1.
Anything raised to 0 is 1. And when you multiply by 1, everything, it just drops out. So we're going to list this answer as 81 y to the 20th. Because anything raised to 0 is 1. Okay? You want to do one more big fancy one like that, or you want to start homework questions? Okay, go ahead and start homework. It's lesson 7-3 in Math Excel, of course.